Assalamualaikum warahmatullahi wabarakatuh. We are from CS 143, Semester 3, Class B. Today, we would like to present about logical equivalent for subject mathematical logic and proving techniques MAT222.
This is our group members. The first one, Muhammad Ali Fikmi bin Jasni. The second, Muhammad Amirul Haziq bin Abdul Latif. The third one, Firhan Azli bin Ahmad Khairul Anwar. And last but not least, Zulfadli bin Mukhtar.
Okay, logical equivalence. Logical equivalence is two statements P and Q that are said to be logically equivalent. If P and Q have the same truth values, and we can write it as P logically equivalent to Q, and when the statement P is true or false, if and only if the statement Q is true or false. Okay, this is an example of logical equivalence question. So it said here that use a truth table to show that these statements are logically equivalent. So P and Q, or not P and not Q, logically equivalent to P biconditional Q. So we start by making the truth table P Q. P is truth, false, false, and Q is true, false, true, and false. So P and Q is true, false, 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 and not P, false, false, true, true, not Q, false, true, false, true, false, true, and then not P and not Q, not P and not Q, false, 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 true, and then we make it A here and B just to make it shorter. A or B, so A or B, true and false, true, false, false, true, and then we look for this P biconditional Q, P biconditional of Q, which is true, false, false, true. Okay, by looking at this, we can see that A or B, which is P and Q, or not P and not Q, have the same two values as P biconditional Q. So it means that since the two values of the propositions, since the two values of the propositions are identical, are identical. Therefore, therefore, the two propositions are logical equivalence. So this is how you prove that both of these are logically equivalent.
Next, we move to the second subtopic, which is propositions of truth value. So the first one, we have tautology. The second one, contradiction. And the last one, contingency.
Alright, tautology. Tautology is propositional statement that is true under any possible true-false valuation of its true propositional variable. For example, using a truth table show that P implies P or Q is tautology. Make a truth table for P and Q. For P, plug in value true, true, false, and false. And for Q is true, false, true, false. And then we find the value for P or Q. P or Q will be false if both of the value is false. Otherwise it's true. So only the last one will be false. Next, for implies the value will be false if the P value is true and Q value is false. Otherwise it will be true. You can see that all the value is true. Hence we can say that since all the truth value are true, thus the proposition is tautology.
Contradiction. Contradiction is a proposition that is always false whatever the truth values of the component statements are. For example, show that the proposition is contradiction using truth table. The question is P and not P. We need to construct the truth table. So the first column is for P and the true value is true and false. So the second column is not P. Then the truth values are false and true. And the third column is for P and not P. The truth values are false and false. Since the truth values are false, therefore the proposition is contradiction.
Contingency. What is contingency? Contingency is a proposition that contains both of the truth values, which is true and false. So, go to example. So the question is construct the truth table to determine whether the following statement is tautology, contradiction, or contingency. P and Q implies not P. So the answer. Okay, the question asks to construct the truth table. So this one is truth table. So we have two variables P and Q. So P and Q. So if we have two variables, we have 4 lines for truth value, which is for P true, true, false, false, and Q true, false, true, false. So we if we have 3 PQR, so the line for truth value is 8. So go to this question. So next, P and Q. So P and Q, the value for truth value for N, we only have true from true and true. Other than true and true, the answer is false. So true and true, P and Q, true and true. So the answer is true, this one. Other than, so true, false, 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 true, false, and last, false, false, same, false. Next, negation of P or not P. So P, not P, if true, the value is false. If false, the value is true. So true, false, true, false, false, true, and the last one, false, true. So the last, P and Q implies. So this one implies not P. So this implies to this. So this implies to this. So for implies, the truth value false if true implies false. Other than true implies false, the answer is true. So this one, true implies false, false, false implies false, true, false implies true, true, and the last one, false implies true. Sorry, the answer is true. So we can see at this we have two truth values, false and true. So we can conclude, since the truth value are true and false, so this one true and false, therefore the proposition is contingency. So back to the topic, contingency.
Okay. This is the example for inverse, converse, and contrapositive. It is said here that write out the inverse, converse, and contrapositive of the following statement using symbolic logic and words. So it said here, if Amin is mindful of his spending, then he can save his money. First, we need to know the P and Q. So the P here is Amin is spending, is mindful of his spending. This is P because this is conditional statement, and then he can save his money. This is the Q. This is the Q. So P Amin is okay. Amin is mindful of his spending, and Q is Amin can save his money. So by this statement, conditional statement, so it is P implies Q.
Next is inverse. We know that Ami is mindful of his spending is P and Ami can save money is Q. We know that this is P implies Q. For inverse, simply put negation on both sides. It will be not P implies not Q. And the answer will be, if Ami isn't mindful of his spending, then he cannot save money.
Next, converse. So now look at the example. P, Amin is mindful of his spending. Q, Amin can save money. Symbol for conditional, P implies Q. So the answer for converse, symbolic logic, is Q implies P. For the word, if Amin can save money, then he is mindful of his spending. So basically for converse is we must change the symbol of variable. So this one is P implies Q, so must change Q implies P.
Contrapositive. We know that Amin is mindful of his spending is P and Amin can save his money is Q. And for contrapositive, the question will be changed to not Q implies not P. And the answer will be, if Amin cannot save his money, then he is not mindful of his spending.
Basically, in this topic, there are three subtopics, which is logical equivalent, proposition of truth values, and inverse, converse, and contrapositive. For logical equivalent, we have two proofs. Two propositions have the same truth values to say that they are logically equivalent. If not, it is not logically equivalent. Next, we have three propositions or truth values, which is tautology, contradiction, and contingency, true and false. Tautology means all truth values are true. Contradiction means all truth values are false, and contingency, true and false, means it has both true and false values. Lastly, converse, inverse, and contrapositive. Converse, inverse, and contrapositive will change the value of conditional statements except contrapositive.